days. We're the only British cash register company left. We've got a lot of experience of mechanical cash registers. We've got a large labour force here in the factory, and we, after a lot of heart searching, decided that the only way we could go forward was to produce our own microprocessor-based cheap cash register.
This explains why. The old-fashioned mechanical cash register needed about 3,500 components to enable it to do simple things like add up, subtract, and give you your receipt. The kind of things you take for granted when you're paying for your goods at a supermarket. Well, now with the new micros, all this will be replaced by this. Just 600 components, 2 circuit boards and a few silicon chips. The firm buys them at the moment from America for £18, but soon they may only cost a few pence. Now, this enables them to produce a machine like this, a micro machine, cheaply, thereby competing with foreign imports.
Yet Chubb had taken over a company with a manufacturing tradition based on making mechanical parts. So with fewer parts needed for a machine based on micros, it clearly meant fewer workers too. The next step was to carry the workforce with them. It was a stroke of brilliance to organise a trip abroad for a party of shop stewards. Chubb took them to a cash register trade fair in Germany to see what the competitors were putting on the market.
My first reaction was, God, we're way behind times, because the machine that we were making at that time was obsolete compared to what we saw there.
And you were convinced then about what?
Well, it convinced me that the company that had taken over would have to go into the electronics field very, very quickly, and they'd have to bring out a new machine basically to catch up with the competitors, and that was just to catch up.
Did you have a hard job selling it to the workers when you came back?
Yes, because basically they hadn't seen what I had seen, and they still had fears about how many people were going to lose their jobs and what was going to take part in the new machines, whether it would be actually feasible or not. Now, but I was convinced it was necessary.
Of course, some people have had to go. There have been redundancies. After all, if the mechanics, which take about 8 hours to assemble, are now going to be replaced by this little chip, then fewer workers are needed. What's happened to this firm could apply to companies all over Britain, whose manufacturing process is based on making mechanical parts. Chubb's finally got it right. They're now in the electronics business, whether they wanted it or not. Gross went out of business. But how many other British firms have realized even now that the manufacturing world is facing its biggest upset since the Industrial Revolution 150 years ago? In the past decade, the introduction of the microelectronic computer, the silicon chip, has changed the whole concept of how industry and those in it will work, and it'll mean a major rethink in Britain. It's everywhere. A new age of control, brought about by sudden access to miniaturized electronic circuits, computers on a tiny chip. Hornby, the name's been synonymous with model railways for years, have been fighting off fierce competition from foreign manufacturers, particularly the Germans. So the companies turned to the new micros to create a revolutionary way of controlling model railways.
Why did you need to develop this system?
Well, we basically felt that the industry needed something different. You had to bring more operational realism into trains, and this is the only way you can do it.
How does it work?
Well, essentially you have coded electronic signals that are mixed with power, and you feed them down the track. The train picks up the signal, it controls the speed as it's commanded from the master controller. You just have 2 wires from the master controller, and that's it. In a conventional layout, you probably would need the equivalent of 1,000 wires. It enables you to control speed and direction of up to 16 locomotives. Yes. You can also control up to 100 points or ancillaries.
This kind of control, and you wouldn't have been able to do this a few years ago, is very important to Hornby, because the company now believes its future is more secure. Unfortunately, the number of examples of British products using micros like this are small. Toys and cash registers are rare exceptions.
I think it has to be an almost instinctive reaction of any designer of any consumer durable, for example, to think automatically about the microprocessor as a way in which he can make his product better.
Microelectronics can help everywhere in industry, starting with the design of parts. At this firm, electronic drawing boards help to create the complicated shape for a car's side lights. A microcontrol model maker makes a prototype from information supplied electronically direct from the drawing board. And in weeks rather than months, the concept can become the finished product. Lucas designed a control system to monitor the gases in a furnace heat-treating diesel parts. This British invention, using microelectronics, is simply fitted on to the Swiss-made furnace. The old rule of thumb way of controlling the gas mixture has been replaced by more exact, continuous microelectronic control. The failure rate has fallen from 30% to nearly zero. The furnace works faster, it saves energy. But again, the number of examples of this kind of application in Britain is small.
Well, the basic national problem is we are not training enough good electronics, mainly good electronic systems engineers, good software people, and even good old-fashioned solid-state physicists. Our universities and academic institutions are just not turning out enough. They're turning out about 25% at the moment of what we really need. Secondly, we have, as I say, been short of the funding in industry necessary to plough back into this very difficult area. And thirdly, I say many of our good people have gone overseas, the people we've already had. So those are three main difficulties that we have to contend with.
But Lucas is a big company. It's got the resources and the know-how. Most people, though, work in small companies. So what about them?
Being slow-moving.
But not
Because
now.
if you move too quickly, I think in some situations you can lose out.
But not
That
now.
is definitely not the case with microelectronics.
It so happens that the Americans have probably got a 10-year lead in the whole field, across the whole field of electronics development, from the chips themselves right across to applying the chips and the microcomputers into advanced systems.
Just the Americans?
Now, the Americans are preeminent, and of course the Japanese have had enough sense to get along very quickly behind.
Why are we so far behind?
I think basically because the environment in Great Britain has not been very conducive to running and working hard in this type of field.
Outside Britain, other countries seem to have met the challenge of the new technology faster than we have. In Sweden, robots are now becoming commonplace. Proportionately, there are 30 times more of these machines in use than in Britain. The one British robot manufacturer sells nearly all his machines abroad. British industry doesn't want them. This one's operating within a big company, so the comparison with Thamesmead is unfair. But it's working in a small space, making the kind of products manufactured by little companies. It's replaced the work of 3 women who used to manufacture the parts this way. In comparison with the human workers, the machine doesn't need a tea break. It can work 24-hour shifts if necessary. Unlike the women, its health won't be affected by the dust in a confined space. Its arms won't suffer any aches or pains, and it's totally flexible. It'll do a wide variety of different jobs. Robots are becoming cheaper than human beings. The perils of industry ignoring this revolution are plain enough to see. Even more uncertain is what the change will do to people. The human being is a fragile creature. Unlike robots, people have feelings like resentment, pride, jealousy, and above all, the instinct for self-preservation. And here, where machines now weld together Saab cars in Sweden, humans are disappearing. By far the most important challenge now facing industry is how to accommodate people and machines. Managements who want fewer workers, workers who'll do different jobs, or no jobs at all if machines do it for them. Once, this man was a skilled welder. Now he watches a robot doing his job. Men are still needed, machines break down. About twice a week, they have to move in and repair them. Right now, this man likes his new job, watching instead of doing. Right now, because he's still got a job to do.
This is much better.
This is better?
Yeah.
Why? In what way?
Because there's not so much physically work. You have not to lift anything, and yeah, it all goes automatically.
Is it a little bit more boring for you?
Some jobs, yes.
Already in Britain, conflicting attitudes between management and unions over what to do about the new technology has resulted in several appalling confrontations. The strike at the Times, which put the papers off the streets for nearly a year and cost Thompson's £30 million, began when management wanted to introduce new computer control machines. The unions worried about who was going to man them and who might eventually lose their jobs. There are grave doubts whether the fragile industrial relations in this country are in any shape to cope with the new technology, whether what actually happened here may be just the beginning.
What's your opinion about the relationship between management and unions in this country vis-à-vis the new technology?
Well, there isn't one. I regret to say it. I will be put in a position, almost certainly, unless attitudes change, in 12 months to 2 years' time, where I'm going to be an unwilling Luddite. I'm going to have to tell my members, and other officers of other unions are going to have to tell their members, to resist technology, because we can't come to arrangements to put the thing in.
Why?
Because we're not getting any response from employers.
In Sweden, their rush hour might be the same as ours, but when it comes to the new technology, they're doing things differently. It's a small country with a high standard of living. Like us, Sweden is dependent upon its industrial competitiveness. Unlike us, the unions and managements are learning to cope by working out the ground rules together.
You can sit down, 10 or 15 people together in your own working place on paid working time and discuss our aims and discuss how you should negotiate with the management about these things.
Now, what's the purpose behind it?
The purpose is that we should be able to negotiate with the management about how computers should be used, so that we, after this negotiation, can tell the technicians how they should work, what they should do.
In other words, giving you the same kind of power as management to